There we go. So I've been programming for about 13 years. I've been at EBSCO for about a year and a half now, I think. And so the topic that I'm going to be talking about today is single responsibility. Now, I didn't tell any of the other guys this, but I was actually really glad that I pulled this particular solid principle because A, it's first, so I get to go first, I get my talk out of the way. And B, it's actually my favorite principle. It's one of the ones that through my career as a programmer, I've gone back to this one principle time and time again, and I can point to it and say that of all of the principles, this is the one that's probably had the biggest influence on the way that I write code and has helped me improve the quality of the code that I write. So let's see what it says. All right, so this is the actual text of the principle. A class should have one and only one reason to change. So this, as all of them, was originally coined by Robert Martin sometime around the mid-90s, but he was not the first one to think of this idea. A lot of this was actually built on ideas that have actually been around since the 60s. There were some studies by a man named Tom DeMarco and others, he's sort of the big name that stands out there, where they did a bunch of studies on different software projects, big projects. And he had a little saying that basically said, if you introduce a gun in Act 1, you better make sure that gun is fired in Act 3. Well, you know, the idea being that don't give promises to your audience that you're not going to keep later, things like that. There's a blog post that I read a while back that basically used the Chekhov's gun in software engineering, but in a bad way. It's that there are little landmines in the code where it looks innocent. You're like, oh, if I just make this one little change, everything will work. But then, unknown to you, you've caused massive damage to like some other part of the system. Like you've just totally broken another feature, and there's no way you could have predicted it. You know, so if your classes have low cohesion, you have this chance of creating like these Chekhov guns in your code or these landmines in your code that are going to trip other people up. Number 3, increases testability. I think we'll have some other people sort of talking about some of the other principles that help with testability, but for single responsibility, if you only do one thing, you're going to have fewer unit tests that you need to write for that test. There's going to be less branching through the code. There's going to be less complexity of the code, so you have to do less setup. The tests are going to be easier to maintain. And then sort of the final point is this increases reusability. You know, one of the problems of like classes with low cohesion is that you can. Yeah. Okay. Okay. I'll try that. Where was I? Okay, yes. So reusability. So if a class has low cohesion, if it's doing a bunch of different things, it's much more difficult to reuse that class in other situations. So that class is kind of geared towards like this one spot. And do I need to? No, you're fine. Okay, cool. Whereas if a class only does one thing, you can reuse that class in multiple different locations. The reusability, this is one of the things I've always taught about object-oriented programming is reusability. But it's like if you don't follow the solid principles, if you don't follow single responsibility, that reusability is a lot harder. You know, you'd be like, I would love to use this particular class over here, but there's like 5 other things that it's doing that I have to work around that makes it more difficult to work around than if I just rewrote the code. So you end up having this problem of it's going to, I'm just going to duplicate code because I can't separate the responsibilities in this other object. So again, another benefit of high cohesion is that you don't have to worry about that, and you can reuse your classes more easily. And I also want to say that although I didn't list it out here, there's an important corollary to this last point, which is to say that if a class only has a single responsibility, it should be the only class with that responsibility. So this is the don't repeat yourself principle. And this is really important because if you find yourself where you're having to write the same code in multiple locations, not only are you repeating yourself, but that's a sign that's telling you, maybe I actually have a responsibility here that I need to separate out so that I don't have to repeat it over and over again. Give you a story of why, of when I started programming and why I actually feel like that this is one of my favorite patterns. When I just started programming professionally, I'd worked with a senior developer who was very smart, super smart guy. And I would sit with him and I'd work with him and I'd see him and he would write lots of code. And he would be able to keep a lot of complex ideas in his head. Like he could jump between UI code and business code and data access code and everything in between like that. And I struggled to keep up with him because it was like that's just how he did it. And so I had a lot of doubt as to whether or not I could ever write code like that or be a good developer like that because I couldn't keep that much complexity in my head. I'd always get confused. I'd get really slow and just generally just didn't think I was doing a very good job. It took me several years to realize that the type of code that he was writing, although he was fast about it, was not cohesive code. He was not following single responsibility. He was throwing together UI logic and data access logic and all these other responsibilities, but that was just the way he thought. He had all this stuff in his head, and he could put it out in code very quickly. And eventually, what I started to realize is that I didn't actually need to do that. The biggest sort of eye-opener for me was that if there was something that I didn't know how to do right then and there, I didn't have to figure it out. I would just create an interface, and I would just say, I'm gonna put this interface right here. It's gonna have a method, and this method's gonna return me whatever I need, whether it's an object or a string or whatever. It's some result that I need. I don't know how I'm gonna get it because I haven't figured that part out yet, but I know I need it. So what I was able to start doing was to start decomposing my problems using single responsibility. And when I started doing that, like immediately my code started getting much better. Because I wasn't having to try to solve every problem in one go. I was basically solving one small problem at a time, and by the end of it, after I had solved all the small problems, the big problem was done. And in addition, my code became very easy to maintain. It was a lot easier to test. It had fewer bugs because I knew each small piece did exactly what it needed to do. So the maintainability went up. The other code, the code written by the other developer, although he could push out features very quickly, they were a source of countless bugs. It's like he could get them out the door, but invariably we'd end up spending weeks or months going back through and doing releases to production to fix hundreds of tiny little bugs that were in his code that could have been avoided had he actually thought about separating out his responsibilities as opposed to throwing it all together. The other thing that it happened, and this is just kind of relating back to all these points here, is because his code was all mixed together, there were no unit tests around his code. There was just no way. It would have been, what few unit tests there were these big, monstrous unit tests that were fragile. So any little change would break the unit test, and it got to the point to where it was just so much work to maintain the unit test that we just decided not to. So you lose that, you lose that safety net of your unit tests. And then the other impact that it had was that his code was not reusable. And because it wasn't reusable, that meant that other developers, instead of trying to pull over that code that might have done something important, but you have to work around all the stuff that you didn't need, they would just duplicate the logic. So you can imagine, as time went on, that if we needed to change some type of responsibility, then now we had 15 places that we had to go remember to go change. And it's inevitable that at some point, working on a feature, you'd forget one of those 15, or 16, or however many, you'd forget one. And you go send it out, and you didn't even realize it. You wrote some code, and you didn't even realize it, and the system's down. You broke everything. And it's like, well, how are you supposed to catch that? These are some of the pitfalls, the landmines of code that is low cohesion. And so once I sort of started really understanding this principle, that really made things a lot better for me in terms of writing better code, writing more maintainable code, less bugs, things like that. So let's get to the sort of the tells you why single responsibility is good. Let's talk a little bit about what a responsibility is. And so I'm thinking that there are probably some questions that you should be asking yourself. So what is a responsibility, and how do I know if my class only has a single responsibility? Like, how do I know when I'm done? And to think about it, I kind of like to think about the idea of the sort of the Euclidean grid, the XY axis. So the way Uncle Bob Martin, describes it is he says a responsibility is an axis of change, which basically means is that it is something in your system that controls how that system functions and behaves. It's a sort of like a knob of behavior, I guess you could say. Another good analogy that I actually thought of last night, I have to share. I don't know why it took me this long to actually think about it, but the human body itself is a good example of a system where you have parts of your body that are single responsibility. So if you think about it, you have a system like your circulatory system, and it's composed of like veins and arteries, and their only responsibility is to get blood to like all parts of your body. And you have the heart, whose only job is to pump the blood. You have your respiratory system, and you have your lungs, whose only job is to oxygenate the blood. So it's like you have all of these complex systems, but they all only do like one thing. They don't do the whole thing. They don't try to do the whole thing. Your lungs don't pump your blood. Your heart doesn't oxygenate. It just moves it around. So a responsibility is kind of like that. It is an aspect of your system or a function of your system that can be controlled. And so if you have one module or one class that's controlling all aspects of that responsibility, then you have to be careful. Then you start actually separating those responsibilities out, and you start reducing the impact that changes to those responsibilities impact other things. There's a term that is brought up a lot that's called orthogonality. And in mathematics, it's the idea that it's perpendicular lines. But it's the idea that if you have two orthogonal lines like the x and y axis, you can move anywhere on that x-axis, right? And you never impact your y coordinate, right? So you're always just on that x-axis. Whereas you can also move anywhere on the y-axis, and you never impact anything on the x-axis. So with an orthogonal software system, the same idea applies. If you know that you've really hit a good separation of responsibilities when you can make changes to one responsibility and it has little to no impact, ideally no impact, on any other responsibility. Is it possible to build systems that are completely orthogonal? I have no idea. But it's one of those that the closer you can get to an orthogonal system, the less bugs you're going to have, the less maintenance it's going to cost, the more flexible it's going to be. So you get a lot of things. So it may not be something that's truly possible, but it's one of those that as you build your system, you should always try to strive for it. Another term for this is basically separation of concerns. Think about what the class is concerned with doing. And if it's doing more than one thing, break it apart. It's much easier to take classes that are broken apart and you could put them back together than it is to take a class that's already, highly coupled, doing multiple things and trying to break it apart. So, as you're building it, err on the side of like, well, let's just break it apart. If you don't know, break it apart. It's easier to put it back together later. So if you look at some of the modern software frameworks like MVC, they kind of follow this idea. You have your view, which is responsible for running your UI. And the only thing that the view knows about is the view model, which, ideally the model doesn't have any business logic. It should just be a simple object that doesn't do anything. It just has values that you need to display on your view. And then when you submit information back to the server, it goes to a controller. And the controller is sort of the entry point to where it responds to actions from the user. And it can, ideally, it can send those commands off to another part of the system to actually accomplish it. Again, if you follow single responsibility, you don't want business logic in your controller, right? But at the end of the day, the controller sends back another another view back to the UI so that you can render back the results of that action. So MVC is a good example of a framework that is built on the single responsibility. You have the separation of concerns. All right, so I want to see a raise of hands here, looking at this class. So we got the contractual obligation of having to show an employee class at every demo here. So here's my employee class. And it has 4 methods: calculate pay, save, which like save to the database, describe employee, which is something that you would return back on like a report, and then find by ID. So based upon everything that I've said so far, how many people think this class has 1 responsibility? Good, good. How many people think it has 2 responsibilities? All right. How many people think it has 3 responsibilities? Okay. And how many people think it has 4 responsibilities? Okay. If you said 3 or 4, which pretty much everyone in here did, that's correct. So this is one of the things about the difficulty of like truly understanding SRP is the idea that how you define a responsibility is a little fluid. It could depend upon your system. So some people would see save and find ID as 1 responsibility because they both deal with data access. Other people say that writing data to the database is a different responsibility than reading data from the database. So it's largely kind of up to your preference or your thoughts on how the system should work as to whether or not you'd want to treat those as 2 or 1 responsibility. There's if anybody went to my talk a couple of months ago about the command query responsibility separation, that kind of is this idea where the whole premise of CQRS is the fact that they say, writing your data commands is a different responsibility than reading your data, which are queries. So they have like this whole idea of how you should architect your system such that your reads and writes are separate. But it's kind of dependent upon your application as to whether or not that's necessary. So that is pretty much all the content that I had. So I've got about 10 minutes or so, a little bit over 10 minutes. So I'm going to go through some demos. I'm going to show this real quick. So this is one of my favorite pictures. Just because you can doesn't mean you should. And so what I'll do is I'm going to quickly go through some demos to show single responsibility in action. And then depending upon how much time we have left over, we'll take some questions and I'll do my best to answer them. So with that in mind, I'm going to go over to my first example. Nope. Let's see. Let's go back to, it went to, there we go. Can y'all see that okay?
You're good, you're a little cut off.
Yeah. I am a little bit cut off. All right. Looks like the left side's a little bit cut off. Okay, so let's make sure that I am actually on the master branch here. I think I am.
Yeah, you are.
Okay. All right, so what I have is a program, and it has an invitation service. So let's say that we're doing a sign up for a website, and the UI has a field where they enter in their name and their email address, and you do some validation on it, and if everything is good, you send out an invitation email that has the links to go do all the sign up stuff. So this is just kind of a small, simple example of that type of service. And let's say, inside here, we also want to do a little bit of logging to make sure that we capture, if they've not supplied their first name or their last name, or the email's not valid, we'll throw an exception, but we'll also go ahead and log it as well. And then down here, we have a little bit of code to go and actually send out the email. So fairly straightforward. How many responsibilities do you think are actually in this class?
At least 2.
At least 2. Maybe even 3.
Yeah, logging being separate.
So let's see how we can actually go about breaking these responsibilities out. So the first thing that I want to do is I want to have the validation of the username, the first name, last name. I want to separate that out. So I want to create, and I don't know if this is still here. Yep. All right, so I'm going to create a file. I'm going to call it username validator. Okay, and it's going to return a Boolean. So validate, and we're going to pass in the first name and the last name. Okay, and then I'm going to take this code. I'm going to move it out of here and into here. All right, now let's see if I can remember what that hotkey is. Nope, that's not it. Format document. There we go. All right, so we got a couple of usings that we have to pull in here. Here we go, use system. The bottom here will just return true. There we go. Actually, if we log, there's really no point in returning true, so I'm going to actually turn this to a void. There we are. That's better. All right, and then the last thing is we need to bring this logging over. So I'm going to take this guy and bring him over here. And we're going to say that this is a username log for username validator. So there we go. And I need to bring in the logging. There we go. This is some of the .NET Core actually added some nice extensions for logging, so now you don't have to rely on like Log4Net if you need logging in your application anymore. So all right, so we'll add that, and so let's go back to our other class. And so now we've taken out one of the responsibilities, but I still need it. So I'm going to new it up right here. All right. And then I'll call, username validator.validate. And then I'll pass in the first name and the last name right here. Okay. So there we go. One of the responsibilities has been taken out. Now, let's take out the other one, which is email. So let's create another class called email validator. So come over here. All right, and it's going to basically do the same thing. Public void validate string email. All right, and I'm going to go back to my invitation service. I'm going to take this out and drop it in here, that. And I need to, I called it email address. So I'll call it email address here. There we are. Let's bring over our logging. There we go. And let's bring in our usings. There's that one. And that one. All right. And go back to our invitation service, and we'll new up one of those guys. So let's say var email validator equals new email validator. And we can say email validator dot validate. I can pass in the email address. There. And the last one that I would actually say is a responsibility that needs to be ripped out is the actual sending of the email. So this could be debated, but you can argue that the responsibility of sending any kind of like notification or messaging or emailing is a different responsibility than just than just the invitation service. There might be other reasons why you'd want to send out emails, like your password's expired, or you need to just send out some mass update to everybody to let them know that terms of service have changed, things like that. So so I would actually say that in this case we'd want to create just an email service, right? And then in here, let's have, let's see, what does this return? This actually, okay, yeah, so let's have it to where it returns a result as to whether or not the email sent successfully. So this case, we'll actually have a Boolean here. Bool send email. And let's see, I can't remember what this type is. I think it's like iFluent email. There's no good emailing capabilities in .NET Core yet, so I had to pull down a library to at least mimic it. This doesn't actually email anybody. So let's see here. Yeah. Actually, you know what I'm going to do? I'm not even going to send over an email. I'm going to send over just the information inside here that I want to actually send. So let's do that. Let's have a string to, string from, string subject, and string body. There we go. Let's just send those 4 things over here. And then take all of this, yank, paste, and I'm going to say, all right, so from, we'll do to, we'll do subject, and, oops, wrong way. And then body, right there. All right, so now we send the message, whatever it happens to be, and we will send back, so we could say, if not successful, return false, otherwise return true, like that. All right, and this one also needs a log, so let's create ourselves a little logger up here, like that, and we'll say this is for the email service. There we are. And let's pull in our usings. There we go. Fluent Core. All right, everything looks good. Let's save all of that. And we need to add it back over here. So let's say var email service equals new email service. That. And then we come down here and say email service.send email. All right, and we got the to, which is the email address here. So we yank that. I don't think I got the whole thing there. Oh, I did, cool. And then we've got this guy right here, so yank, paste. We got the subject. Going off the edge. And then the body. All right. So now, let me format that document again. Shift-Alt-F, that's what it is. All right, so now I can remove all of this stuff down here. And we know that all of that is taken care of inside our email service. So right now, this looks a little, like, okay, we took out a lot of code, but there's other kind of extra code that was kind of added back in. So one of the things that you'll actually hear about from Brandon when it comes time for him to give his talk is this idea of dependency inversion. And so what I'd say is at this point, things like the username validator and the email validator and the email service would all become dependencies on the invitation service. And you don't mind if I really quickly show them that, do you?
No.
Okay. So I'm going to create a...
No, don't show me.
Don't show. I'm not going to show you how to do it. You have to wait. All right. So basically, we're going to have a constructor here. And inside the constructor, we're going to actually take the username validator, the email validator, and the email service, like that. So email service. Boom. All right. And then we'll come down here, we'll create ourselves some private member variables. So private username validator, user. Say what? He's making comments as I'm coding up here.
Pair programming.
With people watching.
Yeah, exactly. All right, so then we'll create a private email validator, like that. I'm actually used to doing this in Visual Studio with ReSharper, and it has like, I could just hit like Alt-Enter, and it says, hey, fill in all your dependencies. I'm like, okay. So here I'm doing it a little bit more manually. And then the last one we want is the private email service. Oops. There we are. So this dot email service equals, oh, I got this backwards here. That should be email validator. And this one should be email service, like that. All right. This is basically now, I don't need them down to new them up in my method. They're going to get newed up when I create the invitation service. So now my send invitation is 3 lines of code. It's very easy to look at this and say like, okay, I know exactly what this is doing. You know, I'm validating the username, I'm validating the email, and once it checks out, I send this email. So, you know, when someone comes in and looks at this class, they're like, yeah, I can understand this. I don't have to dig through 15 lines of cruft to figure out what is actually going on. You know, you've got the essence of the method right here. And so that is a simple example of what you would do in order to start you know, breaking down your responsibilities, separating them out into different classes. It may seem kind of silly. Some of this stuff may seem a little bit like, you know, the username validator was like 3 lines of code. Why do I need to move that into another class? And so, you know, you may sort of want to push back against that. And I'd say, you know, don't actually push back. You know, even if it is just a couple of lines of code, think about now how easy this method is to maintain. Think about how easy it is to test. Think about the number of conditions in which this might actually fail. Like the chances that the code is wrong. You know, very, very low because it doesn't do much. And I think that's kind of the essence of what single responsibility is trying to get to, is that you want to get your methods and your classes to a point to where they look so simple. You're like, there's no way this could break. And that's when you know you've probably got it right. Because then you look at a code and you're like, there's nothing that can go wrong here. Then you've gotten to a point to where you feel confident that the code is doing the right stuff. And you can prove it with tests. So that was my simple example. I don't know, say I got about, how much time, 10 minutes?
You get time.
Okay, I'm gonna go ahead and show my other example, which is a little bit more complicated, but also shows a little bit more about where you can take this. And so I've got an application here. Let me do .NET Run and I'll show you what it does. So imagine you're working for a sales organization and they want a report that gives them a list of like all the products in the database that they just want to have written out to the screen. Okay, so I've got a little database in the back end and it just goes and prints out things like intelligent frozen sausages and fantastic, you know, frozen shoes and things like that. Yeah, there's some really funny ones in here. Okay, so let's take a look at what this query looks like. How many people have seen code like this in your system before? You open a connection, you create a command, you set some properties on the command, you open your connection, you do something like execute reader or data adapter, and you fill in some data, and then you send some stuff back. This, at the outside, kind of looks like it's one responsibility, but is it? That's the thing, is like, you have this query like this, but let's say we also have our order list query over here. Well, guess what? It's kind of doing the same thing. You know, you're opening a connection, you're creating a command, and then you're executing on it. So, as I said earlier, that corollary of that reusability part, it's like if you find yourself duplicating code, that means that most likely these two classes are sharing a responsibility. That means you have this responsibility in 2 places. And that means that they're most likely, both of them have more than one responsibility. The key here is figuring out what those responsibilities are, right? So I would say start simple. Start at the most basic level of what you can pull out. And when I look at this, the first thing that I want to do is I want to pull out this little block right here. It basically takes, to me, it's the easiest thing to start with. It takes the data reader, and it simply reads from the data reader and maps it to a product, which it adds to a list. So to do this, I don't want to hard code too many things. So actually what I want to do is I want to create the ultimate single responsibility interface, the one that you will find vastly useful. If you take nothing else away from this day, remember this interface, IMAP. All right? Does everybody here know what an interface is? Okay, good. So interface is just a contract, right? So we have a contract here, IMAP. What does it map? I'm not sure, but I'm going to handle whatever it can map. So does everybody here know what generics are? Okay, so basically generics are a way of defining a contract, but without actually specifying the type. So in this case, I don't know what the input type is, I don't know what the output type is, but I do know is that I'm going to have a method called map that will take the input type and map it to the output type. That's it. That's the only thing this interface does. So now we can create any number of classes that goes and implements this interface. And so let's say I want to map a data reader to a product or a list of products. So data reader to product list mapper. Data reader to product list mapper. And I'm going to implement the IMAP interface, and I'm going to say my input is a data reader. And it wanted to complete some stuff for me there, all right? And my output, I'm going to say is, because it's a data reader and the reader has lots of rows, I'm going to say that this is an enumerable, which, as we all know, is just basically sort of like a generic list of things of product. That's going to be my output, right? And so VS Code is telling me, like, hey, you got to implement these interfaces here, so I'm going to implement the interface. And there we go. So now I have a class that takes a data reader, returns an enumerable of product. So let's bring in the, actually I think I need to do iDataReader because that's there's not just a data reader class, it's an iDataReader interface is what it is. Let's bring in our other usings. There we go. All right. So I'm going to go back to my product list query, and I'm going to say, take all of this out right here. I'm going to remove that. I'm going to bring that in here. All right. And let's bring this back some more. There we go. All right. So there's a couple of ways we could go about it. I think I'm going to take this approach here. So I'm going to say products equals new list of product. That. And I'm going to, let's see here. Okay. I'm going to change the actual name of the parameter. The nice thing about interfaces, if you could change the name, your parameter name, and you don't have to worry about breaking the contract, which is handy. All right, so we've got a list of products here. So I'm going to read that list, and I'm going to add that product to my list, and then at the very end, I'm going to return the products, like that. And so part of the way this works is like the list class implements IEnumerable interface. So from the outside, they don't care under the covers what that IEnumerable is. It could be a list, it could be an array, or whatever. So people calling this class don't have to care like how I implemented this class. But that's all this does. So take a data reader, and I map the data reader to a list of products. All right, but now I need to actually use that in here. So let's do this. So I don't need this products class anymore. So I'm going to take that guy out. Oops, undo. Here we go. And I'm going to instead say var mapper equals new data reader to product list mapper. And then I'm going to come down here and say, all right, let's return the mapper.map on the reader. So there we go. I'm now returning my mapper. And I don't need this anymore. Boom. So now let's run that guy. Let's see, Control-C, .NET run. All right, let's run our product list query. Everything comes back. So I haven't broken anything. I've just moved some responsibilities out. All right, so let's take the next step and let's separate out the responsibility of setting all this command stuff right here. So this is where, again, just sort of practicing with it, like you start to sort of see patterns here. And so the pattern that I see here is we have two responsibilities. One is connecting to the database. That's one. And that's denoted by the creating the connection and the command and opening the connection and all that stuff. The other responsibility is the actual work that you're doing in the database. And that's all of this fluff in between, right? So I want to separate those out as much as I can. And so what I want to do now is I'm going to create another interface right here. And I'm going to call this iQuery specification. And this is a slightly different use of the word specification. This basically means that I'm going to specify what the query is, right? So public interface, iQuery specification. And what it's going to have, and because this is an interface, we just tell it the type. It's going to have the text. Go ahead and do that. It's going to have the timeout. And it's going to have the command type. Basically, these three things right here. Oops. Thank you. Good catch. It's a lot harder programming in front of 90 people than it is just like on your own. Just All right, so there we go. We got a query specification. And so what I want to do now is I want to have a implementation that represents this product list query. So another class here. And so one of the things I will say that you'll find as you're doing, if you're following single responsibility, is you're going to have a lot of classes. That's okay. You want that. So let's call this product list query. Let's just call it product list query. Oh, I can't use that one because it's already used. So I'm going to call it specification right now. We'll change this later. All right, and it's going to implement iQuery specification right here. And let's bring in the classes. There we go. And so one of the things that's nice about .NET Core, and I forgot about this, so I practiced this earlier and I forgot that I did this. You can actually have getter-only properties, and you can have like these auto-completion things. And that was the first time I had done it, so I'm going to actually take that approach. I'm just going to have these be getter only, and you'll see why in a little bit here. So I'm going to take out all these sets like that, and let me save that guy. Come back over here, and I'm going to take out all of this, that. There we are, and go. There we go. Okay, and so now, actually, I'm going to just have it regenerate because it did it in a certain way that I really think is visually appealing. That, I like that. Very nice. I like how they have the, like this little, you have the, if it's a getter only property, it has like a little lambda expression directly to the thing that you want. I just think that looks really good. So I'm going to take my query text here, come out here and go back. There we go, ink, and go over here and paste that in, like that. All right, timeout. Well, we're just going to make that 1 second here. Hopefully it won't take more than a second. Command type dot text. There we go. All right. So just 3 simple properties. It's nothing too major. Very easy to look at and see what's going on there. But now we need to use that. So let's create a. Let's just call it a. Yeah, let's call it a spec. New product list query specification. There we go. We have our spec. So now I could come in here and say spec.text, spec.command type, .type, I think I just called it type, and then spec.timeout. So looking at just this code down here, here's the interesting thing. Where does it say anything about the product? Like all of that knowledge, all of that information about what I'm doing now has been removed from this class. That responsibility now is elsewhere. I'd say it's been removed. We've moved it to 2 other classes here. And these classes, right now, we just knew them up at the top because that was nice and easy. But there's no reason why now you can't just pass these in, right? So we could pass it in as okay, I want to have this take a product list specification and a data reader to product list mapper. But here's the problem. You're hard coding, again, kind of like what that class is expecting, right? We don't want to do that because that's too many responsibilities. So we actually want to say, well, I just want to take an iQuery spec. And I want to take an iMapper. So iMap data reader, iData reader, to, right now, let's just say an enumerable of product, but we will address this in just a second here. Right? All right, so we're binding to interfaces, okay? So now I can actually get rid of these and say, okay, I've got those defined. Everything still works. I have to go and update my program code now because now that this method actually takes some classes, so I could come in here and say, all right, new product list, query specification, there you go, and then new data reader to product list mapper, there we go. So we'll save all of that, and let's make sure that we can still run. So let's run it again. Okay. I'm almost done. All right, do our list of products. And I know that went by really fast, you couldn't see it, but yeah. So we're still getting our products, we're still getting our concrete towels and all that stuff. All right, so last thing that we need to address here is the fact that we have we still have some hard coding about the product up here in the definition of this method, right? I want to get rid of that, all right? I want to have this, not take any type of knowledge over what is actually coming in. So it's a very, very simple change. I'm going to make this return an enumerable of t, and I'm going to have this take an iData reader, and it returns an enumerable of t. And I have to tell the actual query that there's the t-type right there. So I've now defined some generic types. With that one change, this class now has no knowledge over what the query is running and how it maps the results back to what it's returning. But yet, it still works. Like, it still does exactly what it needs to do. I don't even think I have to recompile. I think everything here just continues to function as is, right? But this is no longer a product list query. There's nothing about products in here, right? This is just let's just say it's a query, or, I actually like the term like a database unit of work. It's like it's doing a single unit of work. So I can actually come here, and I know that there is a hotkey for this, and I don't remember what it is, but I want to rename symbol. And I'm going to call this DB unit of work. And then boom, there we go. So write all of that. Let's go back to our program. So now we have a new DB unit of work, and occasionally code gets a little, or OmniSharp gets a little hung up, and I have to restart so that it picks up. There we go. And so we now have successfully separated out the responsibility of what we do in the database from the responsibility of actually connecting to the database. We could actually take it a little bit further. There's one more step. I got about 3 minutes. I think we got time to do it. So the last thing that we're going to do is, me personally, I don't actually like having both these as two separate parameters I have to pass in. I want to bring them back together, right? I want to kind of like tighten it up a little bit. So I'm going to go back to my query specification, and I'm going to say, as part of the specification, I want you to specify an IMAP of iData reader to an IEnumerable of what? Well, here's where things get interesting. Let's go ahead and just say IEnumerable of t, right? And we'll call this our mapper, and we'll just have another getter right there. All right, and let's add the t type to the interface declaration. So we have that, and let's see what is it. Oh yeah, I need to bring in the IEnumerable namespace. There we go. All right, so now my query specification actually tells me what type I'm working with here. So I could go back to my product list query specification, and I say, all right, I'm going to work with the product now. There we go, and I will bring in the mapper down here at the bottom, And in this case, I'm just going to say new data reader to product list mapper. So I'm just going to have that guy just be newed up on there. And now I can go back to my, where is it? Oh, it changes the name of the type, but it doesn't change the name of the file. That's kind of silly. All right, so I'm still only binding to the interface. I'm going to throw my T-type on there that matches the T-type here. And now I could take off my mapper here because I can get it off the spec. Oh, and I think that's capital M right there. There we go. And so now I've cleaned it up a little bit more, and I've also, kind of, what I would say is that this is a good example of high cohesion. So we had two objects previously that you would have to go modify if you ever wanted to change what that product query did. Well, now they're kind of, well, I say they're closer together. You still actually have to go to the mapper, but you could even see it as, well, instead of actually implementing an IMAP of iDataReader, it could just map a func that takes an iDataReader and returns an IEnumerable, so that you can actually have your mapping code in line here if you wanted to. There's more than one way to do this. But this kind of makes this whole thing a little bit more cohesive. And so now we go back to our program here, and I can just run new product list query specification, and there we go. So we'll build that, and let's run it one more time to make sure I didn't break anything. All right, we'll run our list of queries, and boom, there we go. So everything still comes back. We now have a class that only does work against the database. It connects to the database, doesn't have any knowledge of what it's actually doing. And then we have a second class that is actually defining what it is that you want to do. And so it's not difficult to go from this and then say, okay, well, let's extend that to the order list query. Let's go and implement that one interface. We have our text here, we have our command type, and we have our mapping code. So I can now create new queries, and I don't have to rewrite this logic, this open connection, usings, all this stuff. I don't have to rewrite it over and over and over again. All I have to do is just create more of these guys. And I believe with that, I am out of time, or at least I'm leaving enough time now so we can actually have questions about it. But that is it.
Awesome. So do we have any questions?
Do I need the mic? No, I don't need the mic.
Well, I can hear you, but I don't know if they can.
If you wanted to swap out your data layer here, your database with a REST API or something, how easy would that be? And I know this might be getting outside of single responsibility and into dependency injection or inversion or whatever.
Right.
So.
Yeah, so in this scenario, because this is actually, and the intent is to go to a database, then yes, it would be a little bit more difficult to modify this particular, let me bring it back up again, this particular class. But what I would say is, what I would probably do is introduce another layer on top of the layer that accesses the database and just call it like data access, right? And I don't, or even data persistence. And I don't really say where I get my data from, right? And so you could have an interface that on this data persistence layer that says, all right, I, again, want to just return a list of products. But because everything else is binding just to the interface, nothing else cares where that list of products comes from, right? So you could have, think about it, you can have an implementation to where, first thing you do is maybe go to an external service first, and it can be behind its own, interface or its own classes where its sole responsibility is to go and hit that external service. And if the data is not at that external service, you could fall through and then go query the database for it as well. So you have this is where the reusability and the composability comes in. It's like, I wouldn't necessarily modify this class to try to access an external service. I would use it in conjunction with another class that would actually go to an external service, and I would, bring those together. So does that kind of make sense as to how you would do that?
Yeah, it does.
Cool.
Okay.
I guess my question is playing a little bit of a devil advocate. At some point, are you maybe diffusing too much of the responsibility and kind of abstracting out too far to where, originally you're looking for a product mapper, I want to see that list of products.
Right.
but now I'm defining maps, the queries versus your original goal of just getting the products back.
Right.
Is there a point where it kind of becomes too much of a cost to keep that abstraction?
Let's see here. So the way that I'd answer that is it's kind of, it depends. It's how far or how comfortable you are as to like how far you want to take it. So yes, you probably could take this too far. And in fact, there is some legitimate arguments to where people would say if a class or a method is truly single responsibility, then it should only have one line of code, right? I mean, there is some argument to that. So you have to make a decision as you're designing these things as to like how far you're willing to take it. So I wouldn't say that there's a right or wrong answer, but you could potentially go too far. And so it's a matter of just trying to, the more you do it, the better kind of feeling you get for like what is too far and what's not far enough. And you find what works for you, and then you kind of just start doing that over and over and over again. But yes, you are definitely correct in that you could maybe take it too far.
So one thing I wanted to add, we call them solid principles and not solid laws because there is, that little bit of flexibility. And I know, when I was first really getting into this, like that might have seemed too far for me, but that was because I was comparing against the way I've always done things. So, as you start doing it and you start, and I would even be willing to say that it may be good to go a little bit overboard at the beginning because it's easier to start scaling back as you see where that going that much further doesn't provide the amount of value that you're, putting in as far as cost.
I will say, to sort of add on to your point here, I use the iMapper class. I still think that is a super useful interface. But another way that you could actually implement this to sort of go to your opinion about you're creating a bunch of mapper objects that seem to go too far. You could do like a public func, which we basically know the way the func works is like it could take an iData reader and then it returns, product here. There we go, if I can type. So now your mapper isn't a separate object altogether. It's a func that you can actually supply on here. So you can say like, okay, so here's my data reader, and it goes and does some stuff that ultimately returns a new list. Return new list of product, whatever, like that. And that kind of achieves the same goal at the end of the day of you're getting that mapping code, you're taking it out of the the responsibility of the database class, and you're still binding it next to your query, but you're not having to create a separate class to do it. You're just doing it as like, all right, here's a function, it takes the data reader, it returns a list of product, and that's it. That's all you really need to find. So there's more than one way to go about solving that problem. Yes?
I'm not claiming to be expertise here, but I think to address your concern, you go back to what we saw on the slide. If you go any further, is your code going to be easier to test? Or is it going to be easier to maintain? Or, something like that. I mean, is there another benefit in going further for that particular project, right? In the case of the macro class, I mean, that's, it's more reusable and it's more testable. So yes, let's go ahead and do that, right? Maybe if we broke it up too far, then it's not helping us for this project. So let's stop where we're going. That would be my my logic, right? It's cost benefit analysis. If I spend another 5 hours refactoring my code more to be single responsibility, am I going to get at least 5 hours of benefit because I don't have to write something again? Or is it going to save me 5 hours of writing testing code or something like that? That's the approach that I would take. And again, I'm not claiming expertise,
Right.
but that seems to be what I would look at.
But yeah, I would agree with that. I would say that, again, it's kind of it depends on each application or each system that you develop. It's like it's a cost-benefit trade-off. It's like if it's worth it, continue. If it's not, go ahead and stop.
Do while.
Yeah, exactly.
Do while benefit.
Yes.
Yeah, and I always like to say a lot of this is to help future me, because generally past me is a jerk, and there's a lot of things for future me to clean up. So I'm trying to be nicer to him. Okay, well, if we've got any more questions, we